Good evening, students.
Sir.
Shall we start the rest of the session? Have you done exam well? Hariharan, how was the examination? Hariharan, could you hear my voice?
Yes, sir.
Okay. So that day we have discussed up to enthalpy, heat capacity, bomb calorimeter, heat of reaction, Born-Haber cycle. Up to that we have completed. Now we have to discuss the second law of thermodynamics. So in the first law of thermodynamics, it discusses only about the heat. Okay, it doesn't tell that how the heat is transformed from one center to another center. So and also it is not given any how much work is done on the system, how much work is done. Those things are not discussed by the thermodynamics. But now we are going to see about the thermodynamic, second law of thermodynamics. That's why we need the how much work is done or what is the factor which they decide whether the reaction is spontaneous or not. So some of the reactions are spontaneous, some of the reactions are non-spontaneous. Why certain reactions are taking place? Why certain reactions are not taking place? Those things that can be explained by the second law of thermodynamics. This is the need of second law of thermodynamics. Now, so in the first law of thermodynamics, they have introduced the enthalpy. Now, in the second law of thermodynamics, they have introduced a new concept that is called entropy. So, new concept that is called entropy. Okay. So, what is entropy? That we have to see. Why we are going for second law of thermodynamics? That also we have to see. So, have you seen the Hess law? Yes, Hess law we completed. Application of Hess law we have completed. So from the S law, we can calculate the bond energy and the bond dissociation energy. Now we are going for the spontaneous and non-spontaneous process. What is spontaneous process? What is non-spontaneous process? That we have to discuss. So what do you infer from the first law of thermodynamics, ma? So we have seen the first law of thermodynamics, no? From the first law of thermodynamics, what we have learned? What you have learned, ma?
Sir, U is equal to Q plus W.
What?
U is equal to Q plus W.
Okay, then. Then what else? So the main thing, the enthalpy is the another useful state function that we derived from the first law of thermodynamics, and then internal energy. These are the things we have learned from your first law of thermodynamics. Okay. So the measurement of enthalpy that can be done by the bomb calorimeter. Okay. So now we are seeing that we are in the end of the thermodynamic. Then we have to solve the problems in the thermodynamic also. So what is the limitation of first law of thermodynamics? The major limitation of first law of thermodynamics is it indicates any process that is exactly equivalence between the various form of energy involved, but it provides no information concerning about the feasibility or spontaneity of the process. So limitations of the first law. What are the limitations of the first law? First law. One is, so in all the case, energy is involved, but it doesn't provide no information about the spontaneity or feasibility of the process. That means whether the process is possible or not. But that first law tells that delta H equal to delta E plus P delta V. Okay. For example, so the first law of the thermodynamic does not indicate the heat can flow from cold body N to hot body N or not. All that it tells that the process is occurred. So the heat energy gained by one N would be exactly equal to by loss by other N. So it does not discuss about the first law of thermodynamics. So to answer this question, so same way, the first law does not tell whether the gas can diffused. So does not tell whether the gas can diffuse from low pressure to high pressure, or same way water can itself run uphill. So it is, these are the factors that is not possible, no? So to answer this question, the second law of thermodynamics provided the answer. So however, before we have to take the different statement of second law of thermodynamics, it is important to know whether what is spontaneous process and what is non-spontaneous process, and another two terms, that is entropy gives free energy. So now first, what is spontaneous and non-spontaneous? So what is spontaneous, ma? What is spontaneous? What is spontaneous, ma? What is spontaneous?
Could be at the moment, sir.
Mm-hmm.
Something like I'd say like a quick, sir.
What?
Sudden. Something that's sudden, sir. Spontaneous.
So what are the things that can be happen without doing anything, that is called spontaneous? For example, the water can flow from upwards to downwards. So you don't do anything. When it overflow, it can come down. So that is spontaneous. Okay. So non-spontaneous means, so the process which cannot happen at the room temperature. So by without doing any work, any process is not happen means that is called non-spontaneous. Okay. So when you are taking the sugar, you are added into the water at room temperature. What will happen? The sugar will dissolve. That is spontaneous. Okay. So when you are burning the coal in the air, oxygen. So when the coal is burning means that is called spontaneous. Okay.
Okay, sir.
Okay, ma. See,
Yes, sir.
for example, first you are taken sugar plus adding water at room temperature, dissolution. I mean dissolved. Dissolution taking place, and then burning of coal. Burning of coal in air or oxygen. So in the first, this one can take place itself. Okay, wow. Then it is called spontaneous. Whereas the second thing, that is burning of coal in the air, oxygen, that cannot be taking place. So without doing anything. So it needs initiation. So what we have to do? We have to burn a flame near the coal. Okay. But once it started, it goes on itself by without any external agency. So the both of the processes called spontaneous process. So what is spontaneous process? A process which under some given condition may takes place by itself or by initiation, and the independent of the rate is called spontaneous process. Otherwise, we can call a process which can take place by itself or as an urge or a tendency to take place is called spontaneous process. So generally what we can say, spontaneous process, simple process which is feasible. What we can say, spontaneous process is simply a process which is feasible. That is called spontaneous process. So what are the example for spontaneous process? Example, dissolution of salt or sugar in water, and evaporation of water in a open vessel, and flow of heat from hot end to cold end. Okay, or otherwise cooling down of a cup of coffee, and then flow of water down a hill. So these are called spontaneous process. So these are the commonly takes place by initiation. So by initiation, what are the things can happen? Lighting of candle. Once you are lighting, the candle can burn itself without taking other works. So lighting a candle. So what happened? It involves burning of wax. And then heating of calcium carbonate to give calcium oxide and carbon dioxide. Okay, so these can be happen. And then combination of hydrogen and oxygen to form water initiated by electric spark. In the by electric spark, these are the process which can take place. So what is non-spontaneous? So you tell me what is non-spontaneous? So what is non-spontaneous? So the force which is responsible for spontaneity of process is called non-spontaneous. Okay. So the process which can neither take place by itself nor by initiation is called non-spontaneous. A process which can neither take place by itself nor by initiation is called a non-spontaneous. Non-spontaneous process. Okay. So what are the examples? So we have many examples, that is flow of water up a hill. and then flow of heat from a cold body to hot body. That is not happening, no? From a hot body to cold body, that can be happen. When you are having the flame, you are introducing a iron rod, so the heat can be goes from one end to another end. Whereas when you are having the iron rod in the ice piece, that heat cannot be conducted. Okay, and then diffusion of gas from low pressure to high pressure, and then dissolution of sand in water. So these are the process which cannot be takes place by the, these are called non-spontaneous process. Okay, then we are introducing a term entropy. Okay, so what is entropy? What is entropy? What do you know about the entropy? What do you know about entropy, ma'am? So the process, for example, flow of water from upward down the hill is spontaneous, we are telling. So how it can be happen? How it is possible?
Gravity,
How
sir.
it is possible?
Gravity, sir.
Yes.
Due to gravity, it's rolling down the hill, sir.
So due to gravity. So when you are taking water, adding salt, that dissolved in water, what is that? Why it taking place?
Chemical reaction, sir.
So sum of the force which is responsible for the feasibility of the process. Okay, that is we are call it as driving force. So anything happen because of the driving force. What is the driving force? That we have to give a know. What are the driving force? So we are saying the driving force is a entropy. We are telling that the driving force is a entropy. What is that entropy? Entropy is a measure of randomness or disorder of the system. So what we are saying, entropy. What is entropy? Entropy is a measure of randomness or disorder of the system. For example, one solid is there, you are heating, then it becomes liquid. And then further heating, it becomes gas. So what happened in the solid state, everything's are packed. Okay, so it has a definite volume and definite mass, right? When it liquid, so what are the shape of the container you are taking, that shape it can be converted. Okay, so it is doesn't have the fixed position, so randomness can increases from solid to gas. When it goes gas, it can be anywhere, isn't it? So the randomness of the substance or disorderness of the substance can increases solid to liquid to gas. So by this order, randomness increases or disorder or entropy increases. Okay, so how can you define that? So entropy is a delta S equal to Q by T. So entropy is a state function. Why it is state function? Initial state and final state. It depends upon. So the unit of the entropy is joule per Kelvin per mole. It's a unit of entropy. So for the chemical reaction, change of entropy can be delta S equal to summation of entropy of product minus summation of entropy of the reactant. Okay. For example, at absolute zero, the particle of the substance attain perfect order because all type of molecular motion is ceased. Okay. So that's why Nernst state that at absolute zero, the entropy of a perfect crystalline solid is zero. However, at the temperature or greater than the 0 Kelvin, that is minus 273 degree, the entropy of substance is positive. So entropy increase with increase in the temperature. At standard state, 25 degree, at 1 atmosphere, the entropy is called standard enthalpy. Okay. So the change of entropy can be measured by using the formula delta S equal to Q reversible by T. T is the temperature, delta S change in the entropy. Okay. So always please remember delta S should be positive for spontaneous process. So delta S means delta S system plus delta S surrounding. So when it's always greater than or equal to 0. When it becomes 0 means it is equilibrium. Greater means it's irreversible process. That means spontaneous process. Okay. So how we are telling that delta SF is equal to delta HF by TF. So what is F? And then delta S fusion is equal to enthalpy of fusion divided by temperature of the fusion. Delta S vaporization is equal to delta H vaporization divided by boiling temperature. Okay. So we have adiabatic expansion. In the adiabatic system, Q is equal to 0. So therefore, delta S equal to 0. Thus, the reversible adiabatic process are called isoentropic. That entropic one, the same. Okay. Now, so these are the things which can be taken by the, this is delta S fusion, this is delta F vaporization, and then delta F sublimation also you can take. Delta S sublimation is equal to delta S sublimation divided by temperature. Okay. So we can explain delta S total. That means delta S universe is positive, the process is spontaneous. When the delta S total universe is negative, it's a non-spontaneous. Delta S total is 0, it is equilibrium. So after that, we can have everything in the same form. So now we are going for the statement of second law of thermodynamics. What is the second law of thermodynamics? So many definition is there. I will tell you one by another. So all the spontaneous process or naturally occurring process thermodynamically irreversible. This is the first statement. And the second one, without the help of any external agency, the spontaneous cannot be reversed. So the heat cannot itself flow from colder to hotter body without doing any work. Okay. நம்ம வந்து ஒரு ப்ராசஸை ரிவர்ஸ் பண்றோம்னா we have to do some work. அதுதான் வச்சுப்பாங்க. The third definition, the complete conversion of heat into work. It is impossible without leaving some effect elsewhere. Okay. All the spontaneous process are accompanied by net increase of entropy for all the spontaneous process. The total entropy, sum of entropy changes of the system and surrounding is always positive. Is the fourth. So the entropy of universe continuously increase. Okay. So this is called, all those things are called second law of thermodynamics. These are the laws of thermodynamics. And the last part of the thermodynamic we are there, that is gives free energy or free energy. So what gives free energy or free energy? So it is also another thermodynamic quantity. It also helps to predict the spontaneity of the process. So earlier it was called gives free energy, but according to IUPAC, now it is called gives energy or gives functions. Okay. So the use of the term free energy are not yet been completely stop. It usually denoted by the symbol G. So mathematically equation G is equal to H minus Ts. So we said that it is a state function. H is the heat content, T is the temperature, and S is the entropy of the system. So it is a state function. For the initial, it becomes G1 is equal to H1 minus Ts1, and G2 is equal to H2 at Ts2. So change in that free energy, G2 minus G1 become H2 minus H1, then minus T into S2 minus S1. So the change we can call it as delta G and delta H and T delta S. So this is the Gibbs free energy which relate entropy, enthalpy and entropy for that. Okay, so this equation is known as Gibbs-Helmholtz equation, or simply called as Gibbs free energy. So what is Gibbs free energy? Gibbs free energy is the thermodynamic quantity of system that decreases in whole value during the process to the maximum possible useful work that can be obtained from the system. Okay. So now, so this is the equation for that. Now we have delta H. So when the standard free energy, that means at absolute zero, 298 Kelvin and 1 atmosphere pressure, 298 Kelvin and 1 atmosphere pressure, delta G0 is equal to delta H0 minus T delta S0, or otherwise delta G0 is equal to minus RT ln K, otherwise minus 2.303 RT log K, because when you are changing ln into log, you have to multiply. So this is the standard free energy equation. Now we have delta G, delta H, delta S. If the spontaneous process, what are the things should be that we will have the tabular column? Serial number, delta H, delta S and delta G. And what is the remark? Now we will see first, we are thinking delta H is negative, delta S is positive. When you substitute, this is negative value, then minus into plus, it become minus. Totally delta G become negative. When it's negative, it is the reaction is spontaneous. Suppose, okay, delta H is negative, delta S is negative, negative into negative, positive. Okay. So negative into negative, positive. When it is positive, at high temperature. High temperature. So it is reaction is non-spontaneous. Non-spontaneous at high temperature. That means at low temperature it is possible. That means delta H negative, delta S is also negative. The value becomes negative at low temperature. So the reaction is spontaneous at low temperature. Okay. And the third one. Suppose delta H is positive, delta S is negative. What is the delta G value? What will come up? What it will give? One is positive, another one is negative. Then delta G become? Solunga. So positive, negative into negative, that become positive. So totally delta G become yes.
Delta G.
What?
Sir,
Delta G.
That become positive. Very good. So that become positive. So when it positive means reaction is non-spontaneous. So that type of reaction that will not be happen. That is the meaning. Okay. So fourth one. When the delta H is positive, so delta G also positive, delta S also positive. So automatically it also positive at low temperature. When it low temperature means it is possible. So the reaction is non-spontaneous at low temperature. Then this is positive, this is positive, this is negative when high temperature, because we are multiplying by T, no, that's why high temperature. So reaction is spontaneous at high temperature. So now you look here. So at this temperature, all the reactions possible spontaneous. Okay. So this time when it become high temperature, the reaction is spontaneous. When it low temperature, sorry, at low temperature, this reaction is spontaneous. When high temperature, this reaction is spontaneous. These are the three types of reaction only in taking place. So this is known as Gibbs free energy. And last but not least, third law of thermodynamics. What's third law of thermodynamics? The third law of thermodynamics states that entropy of all perfectly crystalline solid may be taken as zero at the absolute temperature. This is the third law of thermodynamics. So because delta G is equal to delta H minus T delta S, from that we are calculating so many things, which is the positive, which is non-spontaneous, those things we are calculating. Okay, now we can solve the problems in this unit. Shall we do the problems? So now you ask your questions, doubts. Yes. Little louder, ma. I couldn't hear your voice and all.
No doubts.
Yes.
Sir, no doubts, sir, for me.
No doubts, huh? Okay. So now we will do some one or two problems. Then tomorrow also we can solve the problem in this unit. Okay. Shall we do the problems?
Okay, sir.
Yes or no?
yes, sir.
Okay, sir.
Okay, good. Now note down the questions. From the first law of thermodynamics, we'll do first. So for a reaction 2A plus B at gaseous system, okay, it gives 2D gas. So the internal energy delta U0 is equal to minus 10.5 kilojoules, and then delta entropy that's equal to minus 44.1 joule per Kelvin. Calculate delta G0 for the reaction and predict whether the reaction may occur spontaneously. So first, you know that how to calculate delta G. So delta G is equal to delta H minus T delta S. Am I right?
Sir.
So when you are putting delta G0, delta H0 and T delta S0 means at 298 Kelvin and 1 atmosphere pressure only you can calculate. Then what you need? Delta H needed, delta S needed, temperature needed. Temperature because of the 0, so we know that this is the temperature. Now delta S is available, but delta U only available. We have to calculate delta H. How to calculate delta H? Delta H is equal to delta U plus delta NGRT. Am I right? So delta H0 means you have to U0. So now delta U0 is equal to minus, what is the value? Delta U0
Minus 10.5 kilojoule.
10.5 kilojoule plus delta Ng. Delta Ng, how to calculate? Product minus reactant. So you have the two product, but you have the three reactant. So 2 minus 3, that become minus 1. So minus 1, correct? What is the value of RT?
11.5.
8.314 in 10 power minus 3 kilojoule. Then temperature become 298. Why we have taken 298? Because they have given the standard. Standard means 298 Kelvin and 1 atmosphere. It is understood. So when you are doing minus 10.5, so if you are multiplying 8.314 and 298, what answer you will get? 8.34 means 0.008314. That also you can take because 10 power minus 3. Okay, so you tell me what is the answer? So everything in 298, what do you will get? You calculate and tell me. I don't have a calculator.
Doing, sir.
So what is the answer?
Doing, sir. Doing.
Hmm?
Doing, sir, right now.
Okay, okay.
Sir,
Hmm.
for me it's coming minus 252.892, sir.
So 2.48. For me, it's become 2.48. Okay. So when you're doing minus 10.5 minus 2.48, then it become minus 12.98 kilojoule. Kilojoule common, no? That's why they have taken kilojoule. So now you have the delta H0 value. Now you calculate delta G0 is equal to delta H0 minus T delta S0. So delta H0 is minus 12.98 minus 298 minus 44.1 in 10 power minus 3 kilojoule. So everything when you are adding, it's become minus 12.98 plus 13.14 kilojoule. So that becomes 0.16 kilojoule. So totally delta G become positive. When the delta G positive, delta H negative, delta S also negative. Then the reaction should be, see, delta H is negative. So that reaction takes place at 298 Kelvin. Delta H is negative, delta S is negative. At low temperature, reaction is spontaneous. So delta G is positive. Therefore, the reaction will not occur spontaneously or non-spontaneous. Why? Delta G is positive. Delta G is positive and delta S is negative. Delta H is negative. So when you are changing into high temperature, the reaction is positive. So the reaction is non-spontaneous at high temperature. That's why the reaction is not happening. 1, 2, 3. These are the 3 cases. The reaction will not happen. That's why they have mentioned. அதனால தான் உங்களுக்கு ABCD போட்டு கொடுத்துருக்காங்க. ஓகேவா? Now you calculate this equation. So for the reaction, 2 chlorine gas is converted into chlorine gas. Okay. What are the sign of delta H and delta S? Sign மட்டும் சொல்லுங்க. delta G க்கும் delta S என்னவா இருக்கும்? இது எப்படி சொல்றது? How to tell this? So பாருங்க, delta Hங்கிறது என்னது? எண்டோதெர்மிக்கா எக்ஸோதெர்மிக்கான்னு சொல்றத வச்சு வர்றது. ஓகேவா? Now 2 moles of chlorine gas converted into chlorine molecules. So what happened? The chlorine atom forming bond with one more chlorine atom, it gives chlorine molecules. So this reaction is taking place, formation of bond. Correct? When the formation of bond means energy gate, reaction is formation of bond. So the energy gate bond form பண்ணும்போது எனர்ஜி என்ன ஆகும்? ரிலீஸ் ஆகுமா அப்சர்வ் ஆகுமா?
Release.
So energy is released. So when the energy released means delta H is negative. Okay. And then so you are taken 2 molecules and converted into 1 molecules. I mean 2 atoms you are taken and 2 moles of the atom you are taken and 1 moles of molecule is formed. So when you are taken 2 moles of atom have greater randomness than 1 moles of molecule. Therefore 2 moles of atom have greater randomness than 1 moles of molecules. So delta S is negative. When the delta H is negative, delta S is negative. அப்ப reaction எப்படி இருக்கும்? Delta H is negative, delta S is negative. At high temperature means non-spontaneous. Suppose if it is low temperature, it is spontaneous. Okay. So அதையும் பார்க்கணும். இப்படியும் நம்ம வந்து ஆன்சர் பண்ண தயாரா இருக்கும். புரிஞ்சுதா? Is it clear?
Sir.
Is it clear?
Yes, sir.
Sir.
So on the next question, calculate the entropy change in surrounding when 100 mole of water is formed under standard condition. Delta H of 0 is this minus 286 kilojoule per mole. Okay, that means that reactions is hydrogen gas plus oxygen gas. It gives H2O molecule, liquid. So the gas converted into liquid. So the delta HF0 is minus 286 kilojoule per mole. Now what they are asking, calculate the entropy. So what is the formula for entropy? Delta S equal to Q divided by T. This is the formula for entropy. Okay. So what they are saying, 1 mole of water molecule is formed, 286 kilojoule per mole of heat is released. So the heat is absorbed by the surrounding. Correct? Heat is absorbed by the surrounding. So நம்ம என்ன சொல்லுவோம், delta S equal to Q surrounding divided by temperature. அப்போ 286 kilojoule per mole. Why it is positive? Because energy get released means the surrounding என்ன பண்ணுது, absorb பண்ணிக்குது. So surrounding absorb பண்ணிக்குதுன்னா the value become positive. Divided by, at what temperature it taking place? 0, no? And then it is 298 Kelvin. So what happened? Kelvin, no. That is kilojoule. This is Kelvin. This is kilojoule per mole. This is Kelvin. Okay. So when you are dividing 286 by 298, what is the answer, ma? Kilojoule per Kelvin per mole. So what is the answer? 286 by 298. 286 by 298. What is the answer?
0.9.
0.9597. So when you are changing kilojoule into joule, so 959.7 joule per Kelvin per mole. It's the answer. நீங்க உடனே உங்களுக்கு என்ன தோணுனா, இங்க -286 இந்த ஏன் சார் இங்க +286 னா, இது வந்து சிஸ்டம் வந்து ஹீட்டை ரிலீஸ் பண்ணுது, பட் சரௌண்டிங் என்ன பண்ணுது, அப்சர்வ் பண்ணுது. அதனால இது பாசிட்டிவ். சப்போஸ் அவங்க வந்து இத பாசிட்டிவ் கொடுத்தாங்கன்னா தென் இட் பிகம் நெகட்டிவ். அப்ப டெல்டா எஸ் என்ன ஆயிடும்னா நெகட்டிவ் ஆயிடும். புரிஞ்சுதா? இஸ் இட் கிளியர்?
Yes, sir.
So we can wind up to this today class. Tomorrow we will discuss in detail about this problem. Okay?
Okay.
Okay. All of you can leave.
Thank you, sir.